This lesson is on chemical reactions. In a chemical reaction, you have new substances being formed. In this example, you can see that before the reaction, we have the atoms connected in one way, white to white and blue to blue, and after the reaction occurs, they're connected in a different way. And so these are a different compound. This may have totally different properties than they did before, so we have new substances forming. So this is a chemical reaction. And we often abbreviate that RXN. It means you have a change in which new substances are being formed, and to make that occur, you have bonds that are being broken and new bonds that are being formed. And we show that with a chemical equation. We show what's happening. Notice that we're not losing any atoms, that before we had one carbon and after we have one carbon. Before the reaction we had 2 oxygen atoms, and after we had 2. Okay, so what we just said, this in purple is a chemical equation. So an equation in chemistry means this. A formula in chemistry is one of these. So just we have that clear. Anyway, so on a chemical equation, of course, whatever is before the arrow, the carbon and oxygen, are reactants, and whatever is after the arrow is the product. We may read this as carbon combines with oxygen to yield or to form. This is carbon dioxide. If we have a little letter, this is an element symbol, this is platinum, over the arrow or under the arrow, it may actually be like a name of an enzyme or something like that. But if you see a substance there, it's assumed to be a catalyst, something that needs to be present for the reaction to go, or at least for it to react very quickly. On the arrow also, sometimes we have like this triangle. And if you see the triangle, it means heat. It means you add heat for that reaction. It can be above or below the arrow. A lot of reactions will react, but very, very slowly unless you heat them to get them started. We also have state symbols. The S means solid, L for liquid, G for gas, and then AQ is for aqueous, which means that it's dissolved in water. Okay. Another part to the chemical equation are the coefficients, and these coefficients are the numbers in front. This first one doesn't look like it has a coefficient, but it's understood to be a number 1 there. And what that means is that we have one molecule of the C2H6 that is forming 2 atoms of carbon and 3 molecules of H2. And just to remind you, this is a molecule because it has 2 atoms that are bonded together, and of course that we just call an atom. But anyway, the coefficients are important because they show the amounts that react and that are formed. It's kind of like in a recipe. If you have this much reactant, how many cookies you can get out, or something like that. As you probably know, sometimes you have to figure out what those coefficients are. So let's kind of look at why they're important and what can happen if they're not balanced. So here's a reaction. Let's just look at the top one first. Ignore that one. I'm drawing the atoms and molecules that are represented by the equation. So I have an H2, those are bonded together, an O2 and an H2O. Okay. And what's wrong with the way this is written? Well, it appears that I have an oxygen atom that is just kind of disappearing because it's not part of the product. Okay. And that can't happen. when the reaction is balanced, so let's look down here, it's balanced because it has coefficients so that all atoms that exist before the reaction and after the reaction are the same. In other words, here we have two molecules and each one is H2. That's what this means. Here we have one O2 molecule. Okay, and after we have two H2Os. Okay, but if we look at the individual atoms, that is what's balanced. Before, we have a total of 4 hydrogen atoms, and after, I have a total of 4 hydrogen atoms. Works out for oxygen as well. Before the reaction, I have 2 oxygen atoms, and after, I have 2 oxygen atoms. And of course, they're in the water molecules, but they're still there. So we're not losing any atoms. Everything the atoms are conserved, mass is conserved. Let's look at how to balance in a chemical equation. So balancing just means figuring out what numbers to put so that you're not losing atoms before and after the reaction. When we look at this, we can see what's wrong is that, well, hydrogen is good. It has 2 hydrogen atoms before the reaction and 2 hydrogen atoms after the reaction. So we would say hydrogen is balanced. But oxygen, there are 2 before the reaction, and in the product there's only 1. So some people might balance it by adding a 2 here, and that is true that it's balanced now, but when we add that 2 to the end, to the formula, we've changed what compound that is. And you don't want to balance by changing what the compounds are. This reaction is hydrogen reacting with oxygen. It's basically combustion of hydrogen. Hydrogen reacts with oxygen to make water. This compound was hydrogen peroxide, and that's not what the reaction does. So when we do these problems, most of the time we give you what the products are, what the reaction should have, its substances should be, and then you balance it afterward by adding only coefficients. So the coefficients are the numbers in front, and so if I do that, and we'll do some practice with these, but now that's balanced, and what I'm doing is I'm saying, okay, before in the reaction I have 4 hydrogens, 2 times 2, and 2 oxygens. After the reaction I have 2 times 4, that's 4 hydrogens, and then to count my oxygens I need to know that this coefficient multiplies through. So this has 2 oxygens as well. So we say that is balanced. Okay. To balance a chemical equation, there are a couple things that help it go a little bit more smoothly. If possible, start with elements that occur only in one place on each side. And in other words, if I had another product that had oxygen as well, that would make oxygen hard to balance. But anyway, that's kind of a silly example because there's no carbon in the reactants. But anyway, we'll look at some examples like that. So it's nice if there's just one place on each side. And then also if you have an element that occurs by itself somewhere, and by that what I mean by in an elemental form. In other words, if it's just copper or just hydrogen, that's elemental versus being, like in a compound. Anyway, save those elements for last because when you balance those, you don't mess up something that you've already balanced.